Hey guys, today's lesson is going to be how can we tell if we can multiply matrices? Now, in our first lesson, we learned all about what a matrix is. We talked about rows by columns. We could tell the size. You could tell me the entry of whatever the position number was in. Then we went into adding and subtracting, and the biggest thing we hit forth is they must be the same size. They have to have a friend to match up with so that I can actually add them together. And then we talked about a certain kind of multiplication. We gave it a name in front of it. We call it an adjective to describe what kind of multiplying is, because there's more than one multiplication when it comes to matrices. Dun, dun, dun. All right, scalar is actually the easier one, I hate to say, but it is. That is warm, fuzzy feelings of distributive property. You have a number in front of a grouping. Your instinct is to distribute it out. It worked out lovely. You guys, I hope, did very well with that. I know in my heart you guys did. And scalar multiplication isn't that bad. Now, today, we're going to talk about multiplying a matrix by another matrix. And the first thing we have to do is learn to see if we actually can multiply it. What do you mean can? Well, there's rules. There's like a stipulation. There's like one little thing that has to be happening. So we're going to talk about, can we multiply the matrices? These three multiplications down here, and again, they're multiplying because the only thing you can fit between them would be a dot. So I have three multiplication problems here. The stipulation I'm going to teach you right away, it's not that bad, is basically what you want to do is you're going to find the size of the first one. So your first matrix, matrix A or 1, whatever you want to call it, we like to call it matrix A a lot, matrix 1, has a size. It has its rows, it has its column. Then you're going to go, let's do red, matrix 2, your second matrix. And you're going to find its size with its rows and its columns. And the key to being able to tell if you can multiply them is the two closest values, the columns of the first and the rows of the second, need to be equal. Can we multiply the matrices? Only if the columns of the first equals the rows of the second. So let's actually look at this with numerical values. So we're going to look here. This matrix here, this first matrix, is 1, 2 rows by 1, 2, 3 columns. Remember, row, row, row your boat, Roman columns. When I think of Roman columns, I think of Lincoln Memorial with they have so many columns there. It just sticks out for me from growing up and seeing pictures of it and then seeing it in real life. It's just such a beautiful monument. So when I look here, 1, 2, 1, 2, 3, 2 by 3. I'm hoping that you're experts at that. If not, email me, we'll talk. So this second matrix, these skinny ones, they're so nice like this. 1, 2, 3 rows and 1 column. As soon as I write that, I get very excited. The middle guys that are the closest kind of tell me if they're compatible. Are we compatible? Yes, we are. So these two matrices I can multiply by each other. Very, very, very exciting. All right, let's go here. Will purple happen or not? Different color. So these matrices, the first thing I notice is they are the exact same dimensions. This guy here has 1, 2, 3 rows. This guy here has 1, 2, 3 rows. So he is a 3 by 1, 2 columns. And he is a 1, 2, 3, 2 columns. Sticking with my color theme. As soon as I write that, I kind of get disheartened because I notice that even though these two matrices are the same size, they are sadly not compatible. Oops. Every time I touch that little button, it drives me nuts. Sorry about that, guys. These two numbers are not compatible. So sadly, they are not equal. So no, I cannot multiply these two matrices. It doesn't exist. It wouldn't happen. All right. So looking here, this first matrix, they're kind of like, I want to use the word inverse of each other because like this guy here has the rows of this guy's column. So let's see what that does. This is 1, 2, 3, 4 rows. This is 1, 2 columns. This guy here is 1, 2 rows. Oops, let's stick with the color scheme. And 1, 2, 3, 4 columns. And I get excited because I look at them and they are compatible. They pass the test. So these matrices can be multiplied. Their product does exist. This guy here sadly won't have a product, and this guy here has a product as well. So those middle two numbers are what we're really stressing at looking today. All right, now that we can tell if matrices can be multiplied, can we tell anything else before we actually do the multiplying? Because the multiplying is a little bit of a process, which we'll talk about tomorrow. So, just like before, I'm going to talk with the size. 1, 2 rows, 1, 2, 3 columns. All right. 1, 2, 3 rows by 1, 2 columns. Now, the directions kind of implied that we can multiply these, so these numbers should match, which they do. Woohoo! But now I'm going to tell you that we can even go a step further and tell you what the size of the answer is going to be. The rows of the first guy and the columns of the second matrix that are compatible will give me the size of my answer. So the answer of this times this will be a 2 by 2 matrix. So when I do this, I will have 2 times 2 is 4 entries. I'll have an entry here and here and here and here, 2 rows, 2 columns. It'll be beautiful when we do it on the next video. That's it. Woohoo! All right, so let's look at this guy. Now, we already know they're compatible because the directions say we can multiply them. What else do I know? So this is 1, 2, 3, 4. Oh, we just did this kind of up top. 1, 2. And this guy here is 1, 2 by 1, 2, 3, 4. Are they compatible? Do we have a match? Yes, we do. Woohoo! What's the size of the answer? 4 rows, 4 columns. Now, wait a minute, Frybush. We went from 8 things times 8 things. We end up with 16 things. Oh my gosh. But here we had 6 times 6 things. We end up with 4. Yes, it's all about the rows and the columns and how they're going to match up. So in this guy here, I am going to have 1, 2, 3, 4 rows, 1, 2, 3, 4 columns, and it's going to end up being 16 entries for this guy. Okay, so even though they're compatible and even though you look at their original size, their answer size are going to be the rows of the first and the columns of the second, which is why it's nice to do this before we actually do the multiplying so you know how much to expect math-wise. Okay, so I have this little table here. Here is your first matrix. Again, we're going to call that matrix A lot of places. A matrix is always going to be named by a capital letter, just letting you know that. That's big. If you have your scientific calculator with you, there's actually a matrix key. I'm going to try my best to show you how to use that if you have your calculator. If you don't, no worries. I have great ideas for how to get along without that. I've found some great programs online. Matrix B, it's capital. It's usually the second one, okay? So I just want you to know, if I tell you the dimensions of matrix A and I tell you the dimensions of matrix B, does the product A, B, does A, B exist? Yes or no? So let's go through and do these ones. So if I have a 2 by 8 times a 2 by 8, they match, but I care about the end of the first, the beginning of the second. Are these compatible? Womp, womp, womp. Sorry, no. What about a 4 by 5 and a 5 by 4? The 5 and the 5 match. So, yes. If at any time you want to pause this and check before I give you the answers, go ahead. Here I have a 6 and a 1, so it'll be no. Here I have a 1 and a 1. It'll be yes. Here I have a 10 and a 1, and again, I'm only looking at the middles. I don't care about the beginnings. The beginnings will tell me my answer size if I have a yes or a no. This guy here is a 7. This guy here starts with a 6 and a 7 and a 6. Sadly, not compatible. 3 and 3, they match. Yeah! So the only ones that I could have a follow-up questions would be for these ones that have yes. So here, this guy here, 4 by 4 would be the size of it. Here it would be 1 by 1, and here it would be 3 by 1. And if you didn't catch that, don't worry, we're going to do some right here. Okay, the next set of questions I have is, what is the size of the resultant matrix of the following problems? This matrix right here is a 3 by 2. This matrix right here is a 2 by 3. They are compatible. What is the size of their answer? Well, the only thing not circled, 3 and 3. Okay. What about this guy? Well, here the 4 and the 4 match. So 2 and 1 would be the answer. Now, I put brackets around this because matrices are known for their brackets, but I don't need it in the answer. I just need the 2 by 1 like that. Here, ooh, this looks kind of confusing. Well, that's because these matrices are so tiny. There's a bracket around 7, 1 row, 1 column. This is a 1 by 1. This guy here is also a 1 by 1. It's one entry in a bracket. It's 1 by 1. These ones match up. So my answer will be a 1 by 1. And oh my goodness, what did I do to you here? This is just to kind of get you to think. Now, these here are parentheses, different than a bracket. A bracket has those nice, like, really 90-degree angle kind of things. Now, if I add a 2 by 2 and a 2 by 2, the resultant will be a 2 by 2. And this guy here is 2 by 2. If I multiply this guy times this guy here, they're compatible, and my final answer will be a 2 by 2. I don't know why I wrote 3. It's one of those days. All right, so what I would like you to do for this first lesson is, I have this on the printable if you want to print it out. Otherwise, you could just write it on another piece of paper. In the next video, I'll post the answers to this one, but I want you to tell me, does the product of the following matrix exist? And if it does, what are the dimensions? So you're going to write down the size of this guy, the size of this guy, and then what size does it equal? Okay? So try these 8 problems on your own to see if you understand this task.